and welcome back to the API of New Hampshire Delta T technical video series. In this video, I'm going to introduce you to the LGMV tool, simple device that you plug in to the outdoor unit for both the residential and the commercial product line. It allows you to connect via Wi-Fi on either a tablet or on your phone. After you download an app that's free, you have access to reading system pressures, target pressures, all kinds of information that is extremely helpful while diagnosing LG service issues. The tool comes with 3 pieces. It comes with the Wi-Fi module, the connecting cable, and an adapter to go from our residential size equipment to our commercial equipment. We'll review that in detail shortly. We're back here in the Manchester, New Hampshire training facility, where I'm going to show you how hooking up the LGMV tool is so easy you can do it standing on one foot. On the LGMV tool, as I said earlier, it comes with an adapter to connect to our commercial product line, Multi-V. Here I have a Multi-VS, a side discharge unit. The connection point in here is hidden behind a very convenient cover. You simply remove the cover. You need to use the adapter, and the adapter would plug in to the side of the unit like this. Today we're going to be connecting to a DFS unit, residential. I'm going to connect to this unit, and I'm going to show you the way the display will look on my iPad as well as on my Android phone. It's going to look different depending on which device that you use. However, you will have access to the same information. Again, I'll walk you through some of the differences, some of the highlighted features that you want to look at. On the residential equipment, on the smaller size things, there's going to be an adapter whip that you can plug into near the electrical connections. If your system does not have the whip, go to the main board and look for a 4-pin flat connector marked LGMV. Here I do have the whip, so I will plug into it. I'll give it a second to recognize. You'll know that it's connected and transmitted when the green light flashes. Once you have the app downloaded on your phone, you can see it here, LGMV Business. Before you try to connect to this, it's good practice to first go to your settings screen, scroll up to your Wi-Fi connections, and be certain that you've connected to it here. If you've connected to a different Wi-Fi network and it will not allow you to connect to the LGMV. When you confirm that you're connected, go ahead and open the app. I'm using my iPhone for this example. We'll select monitoring data. You see it's already paired up to use Wi-Fi. Press the arrow to the right, and we'll see that we're going to connect. The green dot means that it's going to be a good connection and we can move forward. Hit the arrow again. You may get a pop-up once you've used the tool a few times asking you if you want to do this auto discovery. Unless you're confident you're reconnecting to an identical unit, always select no. That's what I'm doing now. Now we have some information that has to be entered into this. We have to select model group here at the top right-hand corner. We're working on a single multi-system, so we'll select that. If I was working on a multi-V system, I would be able to select that up here, whether it would be an ARUM, a heat recovery, a heat pump model, a multi-VS, and so on. We'll keep it at single and multi since that's what I'm connected to. The unit that I've connected to is an LMU 300 HHV. It has the capability of having 4 ports connected to the outdoor unit. So here under IDU, you want to select 4. It should find that on its own, but if it doesn't, always select the maximum number of indoor units that can be attached to the outdoor unit. I'll talk about that more shortly. In this bottom section, some information needs to be added in here in order to move forward. Distributor, installer, model, and site. These fields need to be filled out in order to move forward. Here under data, this is where you would come in and begin saving if you wanted to do that after the fact. I'm going to select stop saving simply because you can't make the next adjustment while in saving mode. Under settings, unit conversion, this is where you can turn it from Celsius and go to Fahrenheit and go to PSI, thousands of BTUs per hour and gallons per minute, bringing us into our more common American system over the metric system. That's something that you'll need to do when you open the app for the first time. Under the status bar near the top, it says the words OK. That means we are connected to the unit and we are receiving information. The sun means that we're in heating mode. You get a pop-up asking if you want to do recording of data. We'll click OK. If you don't want to record data, you certainly don't have to. You can turn it off in another screen. This unit has been running for a little bit of time, but it's important to note that until it has run for 15 minutes, you don't want to trust any of this information. Here under the basic info tab, we see that our high pressure target is 429 PSI. High pressure trace is 429 PSI. The target pressure is what the algorithms inside the computer have calculated it would like to see based on the conditions. And the high pressure trace is what the system is actually measuring. They should be within 10 pounds of each other in heating mode. In heating mode, we don't pay attention as much to the low pressure as it won't be as accurate in some cases. We really focus in on the high pressure. All the way down at the bottom of this list, we see inverter discharge temperature target. TGT is target. This is also an important number to keep track of. As we want to get more information across the top, we just select different info. Here's some valve information. We see that the 4-way valve is illuminated green. That means that we are in fact in heating mode and that has been energized. Actuator info, inverter 1 target, inverter 1 trace. This corresponds to the speed of the compressor. With an inverter compressor, we modulate capacity in order to meet indoor requirements. That's reflected in the inverter target and inverter trace. Below that, we see fan target and fan trace. And again, we can see that they agree with each other. Anytime that we are talking about a target and a trace, they should agree with each other. Sensor info. This is actually information for the outdoor unit. Air temperature would be the outdoor ambient temperature. I'm indoors in our training facility, so it is showing an air temperature of 78 degrees. Naturally, that has an effect on the pressures that we'll see going through this example. Coming down this line, you'll see inverted discharge temperature once again. I'm going to go back to basic info. 147.2 is the inverter temp target. And here we see the trace is 149 degrees. So we're right on track. The inverted discharge is measured right at the outlet of the compressor. LG has designed their DFS equipment to begin limiting if that temperature reaches 203 degrees, at which point the compressor will slow itself down. It's very important to keep track of those numbers. Electrical info, inverter input CT, that's the amp draw of the inverter circuit. Inverter 1, input VT, that's the voltage coming into the unit. And below that, we see the frequency or the hertz. Again, these numbers would all agree with each other as we go down. Indoor unit information. Again, we're in heating mode, and you can see that by the suns under mode. To the left of the suns, we see under capacity 12 and 12. That is the indoor units that it's attached to. Both of them are 12,000 BTUs. Moving to the right, you can see the EEV position. You can see the air temperature inside the room. You can see pipe in and pipe out temperatures. That top unit has a pipe out temperature of 140.7 degrees and a pipe in temperature of 103. It's important to note that in heating mode, our pipe out sensor is in reality the inlet of the coil. Being in heating mode, our refrigerant cycle has been reversed. Pipe in becomes pipe out becomes pipe in. (140 degrees going into the coil, 102 degrees coming out. The unit is doing some very good work in this case. Under flow, the 3 green waves, that is an indication that we're on high fan speed on both of these units. Earlier, I mentioned that it's important to note the maximum number of indoor units for any system when you go into the tool. If you don't do that correctly and someone installed it and skipped a port outside and you only select 2, they won't necessarily find what you're connected to. It's always best to select the maximum so that they all show up on this screen. If there's ports that have nothing connected, you'll have 0 capacity, and then you'll see these odd numbers at the end where they all say 572. Anytime a number doesn't make sense, it's a garbage number or a nonsense number. Coming back over to basic info, we can see that our pressures are still running nice and strong here and agreeing with each other. If you're doing a preventative maintenance or a new startup, this is all the information you really need to look at to be sure that it's running well. Okay, I just switched this unit over to cooling. You can see that by the blue snowflake under the mode section. It's only been running in cooling for a very short time, so we don't have a target pressure or anything else that's populated as a target, simply because the system hasn't run long enough to process where it wants to be. Again, I'm indoors in the Manchester training facility, so the temperatures and the pressures may look a little odd. Moving through the tabs while we let the system catch up, under valve info, you see that the 4-way valve is no longer energized. Again, we're in cooling mode, and in LG units, the 4-way valve or reversing valve is powered for heating mode. Actuator info under this tab is where we see our inverter target and inverter trace. They're both showing 35. That's the calculated speed of the compressor based on the anticipated load. On a startup, the indoor unit sends data back outdoors, room temperature and target temperature. It also looks at outdoor ambient temperature, and it sets a starting frequency. In this case, the unit has selected 35, and now it is running. You can see that the fans are also starting to even out with each other as well. Sensor info, this is the same information that we were looking at before, where we have the air temperature, that's outdoors. You can fill those things in on your own moving down. And inverted discharge temperature is 122. Again, we expect that number to stay on the lower side, around 160 usually. Electrical info, we have a lower amp draw than we did in heating mode, simply because the capacity is reduced. And here in the indoor unit, we have the same two units running, 12,000 BTUs each. You can see the position of the EEV. And here, pipe in and pipe out reflect actual pipe in and pipe out on the top tab. Again, in cooling mode, our refrigerant flow is normal. We reverse it in heating mode, and that's why pipe in and pipe out will be different. As this runs longer, we would see that the pipe in temperature and the pipe out temperature will start to have a variation. Back in basic information, we have a high pressure target of 263 and a high pressure trace of 258, and we're still waiting for that low pressure target to populate. Thank you for checking out this video. I really hope you enjoyed it and you found it useful. We'll see you back here again soon as we continue to help you grow your business every step of the way.